What if I told you that every time a 3D printer creates something, it's solving hundreds of math problems every second, from phone cases, to medical implants, to parts used in space? 3D printing doesn't work without math. Today, I'll show you how math controls precision, shape, speed, and strength in 3D printing, in a way anyone can understand. At its core, 3D printing is all about coordinates. Just like points on a graph, every movement of the printer is defined using X, Y, and Z values. X moves left and right, Y moves forward and backward, Z moves up and down. Every tiny point of plastic is placed using geometry. Curves, circles and angles are all broken down into thousands of small straight paths that the printer follows precisely. No math? No shape. 3D printers don't print objects all at once, they print layers. Each layer is incredibly thin, often just 0.2 millimeters thick. That's math using fractions, decimals, and precision measurement. If the layer height is too thick, details disappear. If it's too thin, the print takes forever or fails. The printer constantly calculates how much plastic to release, how fast to move, and when to lift to the next layer. Perfect prints depend on perfect calculations. Speed is another math problem. Printers calculate rates like millimeters per second, extrusion speed and cooling time. Move too fast, the plastic doesn't stick. Move too slow, the print warps or overheats. The printer constantly balances speed times, temperature times distance, to get the job done correctly. That's real-world algebra in action. Before printing starts, math does most of the work. Special software called a slicer takes a 3D model and breaks it into layers, calculates toolpaths, and determines infill patterns. This uses algorithms, optimization math, and spatial reasoning. Infill patterns like honeycombs or grids are designed using math to make objects strong but lightweight, less material, more strength, all thanks to math. Math even decides how much material is used. Printers calculate volume of the object, density of the plastic, and total weight of the final print. That's geometry and measurement working together. Without these calculations, prints would waste material, break easily, or fail completely. So the next time you see a 3D printer at work, remember, it's not just melting plastic, it's using geometry, algebra, fractions, rates, and algorithms all at once. Math isn't just in textbooks, it's building the future, one layer at a time. If you enjoy seeing how math shows up in everyday life, hit like, subscribe, and let me know what device or technology I should break down next.